Industrial drying processes require each day a vast amount of energy. So how can we make this more efficient? In order to discuss these questions, we are today at the Fraunhofer Institute for Laser Technology, which is one of the most important research centers of its kind worldwide. And here we'll meet today Samuel and his team who are performing research specifically on the question how can we use laser drying for more sustainable laser processes. So let's have a look and let's go in. Hi Samuel, good to see you.
Welcome to Fraunhofer ILT. Thanks for coming over. Are you ready to see our laser drying system in action? Then come along.
Great, thanks.
This is the coating machine or system that I've been talking about and that I wanted to show you. Contains a coating system or coating module, a hot air dryer, which we use for benchmarking, and then the laser drying module that has been specifically developed. So at the moment, we're focusing on electrodes for lithium-ion batteries, but we also do research in electrodes or materials for fuel cells, printed electronics, basically every process that needs very well controlled and fast and energy efficient drying process. So in this laser drying module, we integrated two of your LDM systems. Together with optical systems, we were able to create two large laser spots, which cover combined 0.8 meters. This is the thermographic camera, and we use that to measure the temperature during drying and use this data to control the power output of the laser. And this gives us a very high level of control over the temperature and also the drying conditions.
So I understand now you basically have those rectangular laser spots and electrode which focus exactly just on the area that you need to heat. And I also see that you have the convection drying system here. So what is the difference between the energy interaction?
So the biggest difference is probably the way how the energy is put into the electrode. In the convection drying, it's via convection of hot air, which is not very efficient.
So you first have to heat the air and then you heat the electrode.
Exactly. And when you use laser radiation, the radiation is absorbed by the material and heats up the material directly, which makes the energy transfer very efficient. We are still investigating how this process scales up, but our current estimate is that you can save between 30 and 50% of the energy that is required for drying by using laser radiation.
And I understand you can very rapidly heat up. Does that also have an impact on the footprint of the complete system?
Yes, it has. The drying system takes up a lot of space in industrial electrode manufacturing. And by using laser radiation, this footprint can be reduced drastically. Currently, we're estimating between 50 to 70% less space that is required for the whole drying system.
And still you can save in total half of the machine footprint and also operating costs. So how do you see the perspectives of the system?
With this system, we have moved already quite close to the industrial scale. And we are able to look into scaling factors and components that have an impact on the drying system on this scale in a continuous process. So the next step would be to go further and go from the current lab or pilot line to a industrial scale level.
Yeah, great. Then let's have a look how this scales up in the for production systems. Thank you.
Okay.